We've been studying a lot about functions, function tables, function rules. Now we're going to move into functions and equations. Okay? You can use an equation to represent a function. The input, or the independent value, represents the x value, and the output, or the dependent, represents the y value. An equation expresses the dependent value in terms of the independent variable. Okay? Now, let's do some examples. Let's figure out what that all means. Okay, here's an example. We want to write an equation to represent the function shown in the table. So this and this is the same information, okay? So we have input of 1, output of 9. Input of 1, output of 9. Input of 2, output of 18. Input of 2. Okay, so you can see these are the same tables, just written different ways. This one right here shows the function rule. This one right here does not show the function rule. Okay? So, we know that the value of y is 9 times the value of x. The way you go from here to here is you times 9. And the way you know that is because you're plussing 9 each time. 9, 18, 27, 36, 45. So you plus 9. Every time you go from here to here, you go up a 9. So you're multiplying it by another 9. Okay, so the equation represents the function is y, the output, equals 9 times x. Okay, so the function is the equation 9 times x, and this is y. So no matter what x is, you're going to times it by 9, and then you'll get your value of y. Okay? Let's try it with this one here. So we have input and output. We're going to write an equation to figure out the function. Okay? So what I'm going to do is I'm going to set up a little table here. So I want my in, I want my out. This is my x, this is my y, and my function rule is going to go right there. Okay, so let's see what we have here. 1 goes in, 16 comes out. 2 goes in, 32 comes out. 3 goes in, 48 goes out. 4, 64, and 5, 80. Okay. So, what's happening from here to here to here to here? 16 plus 16 is 32. 32 plus 16 gets me to 48. 48 plus 16 gets me to 80. Okay, so it's plus 16. So it is x times another 16 every time we go up. 1 times 16, 2 times 16, 3 times 16, 4 times 16, 5 times 16. So my function is y equals whatever x is times 16. So 16x. And there is my equation to figure out what y and 16 is. Because I know I'm going to test it. I know y is 16 on the first one, and I know equals 16 times x is 1. Do those equal? Yes. Okay, so we got an equation then. Now we can graph these equations. So you can graph a function. If the graph is a line, the function is called a linear equation. So linear means a line, a straight line. When graphing the function, the input is the x-coordinate and the output is the y-coordinate. Okay? So it always goes x, y. X, y. And x is down here, and y is there. Okay? So let's practice some of these. Whoops, let's do that. Okay, let's look at this example here. It says graph y equals 2x. So we have this equation, and I could put it into a chart. Say my x, oh, I went too far. There we go. Say my x right here, I put that in here, and it's 0. So 2 times 0 equals y. What's 2 times 0? Well, it's 0. So y equals 0, which is what I have here. So if I put 0 in as x, I'm going to get 0 in y. If I put 1 in for x, it's 1 times 2, it's going to get me 2. If I put 2 there, it's 2 times 2 equals 4. Okay? So my equation is this y equals 2x. Now, graph each ordered pair and draw a line through each point. So here's my x, and here's my y. So 0 on the x, I go to 0, and I go to 0 on the y, it's right there. Now I'm going to go to 1, which is right here on the x, and I have to go all the way to 2 on the y. So I go up, and it's this point here. Okay? Now 2 on the x is right here, and 4, I go from 2 all the way up to 4, it's right there. And then I connect my dots, and I can keep going on. It's a straight line, it's a linear. I could look at this graph and kind of see all the points on it. Okay. Let's practice some of these. So we want to graph this equation. Y equals x plus 1. Okay. I'm going to make a little chart here. This is my x, this is my y. So I'm going to start with x being 0. So I put 0 in there, 0 plus 1 gives me 1. Okay, now let's do 1, 2, 3. I'm going to do points 1, 2, and 3. If I put 1 in there, 1 plus 1 is 2. If I put 2 in there, it's going to get me 3. If I put 3 in there, it's going to get me 4 for y. Now I'm going to graph it. All right, x is 0, y is 1. So my first point's right there. X is 1, y is 2, so it's that one. X is 2, y is 3, x is 3, y is 4. I connect the dots, and it's going to be a linear straight line right through there. Okay? Let's do C. We have y equals 3x plus 2. Okay? I'm going to just do a little table. Do a little in, do a little out. Okay? And I kind of like to start with 0. Let's just go 0, 1, 2, 3. We can go to 4 this time. So 0, 3 times 0 is 0 plus 2 is 2. 1 times 3 is 3 plus 2 is 5. 2 times 3 is 6 plus 2 is 8. 3 times 3 is 9 plus 2 is 11. let's see, 4. 4 times 3 is 12, plus 2 is 14. Kind of see how it's going up 3 each time. Okay, now let's graph this. So 0x goes to 2 on y, and then we have 1 and 5. 1x goes all the way up to 5, and I am out of graphing possibility. 2 and 8 is way somewhere up above. So it is going to be a linear line. I just don't have enough graph paper. Okay? All right. Let's go on. Let's do another example here. Martino constructed the graph shown, which shows the height of his cactus after several years of growth. So here's how many years of growth. Here's the height. This is the x, so I know this is going to be the in. I know this is going to be the out, because this is the y. Okay. So make a function table for the input values. And they've done this for us. So the 3 input values are 1, 2, and 3. So for 1, it's 42. For 2, it's 44. For 3, it's 46. Okay. So we could actually create, it doesn't ask for this, but I'm going to do this. Do this anyways, just for fun. It's going up plus 2 each time. So it'd be 2x, so 1 times 2, and then plus 40 to get me to 42. So this is my equation. Let's see if it works for 2. 2 times 2 plus 40 is 44. 3 times 2 is 6, plus 40 is 46. Okay? Oh, I think the next one is asking me to write the equation. Okay, well, extra practice never hurts. Okay, let's see what we got here. This one says, write an equation from the graph that could be used to find the height of the cactus. And I just did this for you, and I was right. Y equals 2x plus 40, because we have to go twice plus. It's going up by 2 every time, so it's 2 times, and then I add 40. Okay. Cool. Last one here. A got it problem. If you want to try this one on your own, pause the video, and then come back and see how I do it. You can do that, or you can just watch as I go ahead and do this. The graph shows the total amount of Y that you spend to buy one book. Okay, so my Y, which is over here, is the amount of money I spent, and the X, which is right on this line, is the number of magazines I bought. Okay, so this is my input, this is my output. So if I bought 1 magazine, it cost me $20. Okay. If I did 2 magazines, it cost me $25. If I bought 3, it cost me $30. I forgot to put my input. And then for 4 magazines, it cost me $35. Okay? Now, so I got my chart. 1 input gets 20 output. Now, I want to write my equation. Y equals, what's going on here? 20 to 25 is plus 5. 25 to 30 is plus 5. 30 to 35 is plus 5. So I'm doing another times 5 every time. So I'm going to do x times 5. And then I have to add something to get to the right number. So if 1 is x, 1 times 5 is 5, plus I need another 15 that will get me to 20. Okay? So here's what I think my equation is. I think my equation is y equals 5x plus 15. I'm going to try it with 3. 3 is my x, so 5, I put my 3 in there, plus 15, and 30 I know is my output, my y. So let's see if this is a true statement, okay? 30 equals 5 times 3 is 15, plus 15. 30 equals, now 15 plus 15 is 30. That does equal, fantastic. Okay, so hopefully in this lesson you've got an idea of how to graph something, how to write an equation that represents a function. Okay, and we are going to do lots of practice with this. Okay.